Hello, in this tutorial we are going to learn about overlap in reinforcement. So let's see the definition first. During placing the steel in RC structure, if the required length of a bar is not sufficiently available to make a design length, then lapping is done. So, lapping means overlapping of two bars side by side to achieve required design length. And here you can see the example for overlapping. This is the overlap over here between two bars. You can see here and here as well. So let's see the overlap in different structure. And here the first column neck to column overlap. Here you can see we have just this column next that is starting from the foundation. Okay, you can see here it is starting from the foundations up to ground level. This is called as column next, and it is going to connect with the column to the superstructure. So this overlap is equal to 40D to 50D. Okay, this overlap. Now the next column to column are beam overlapping. It's mean that if you are going to connect it two columns in superstructure, the lap will be equal to 50D. Okay, both in beams and column as well. Now the next is development length. And what is development length? This is the development length over here. This is the bend. Okay, and this is called as development length. It is going inside the foundation, okay, to connect these dowel bars to the distribution bars. Okay, so this bend is called as development length, and it will be taken as 16D. Now the journal overlapping is equal to 50D. So this is all about overlapping in different structure. Now the next thing here is concrete cover. So what is concrete cover? Distance between the outer surface of the concrete to the inserted reinforcement is called as concrete cover. Mainly we have just two types of concrete covers. One is called killer cover and another is called as effective cover. So this is the example for killer cover. You can see here it is just starting from the outer surface of this concrete to the outer surface of this stirrup. So this is called as killer cover, and from the mid of this to the outer surface of this concrete cover, this is called as effective cover. And in different kind of structures we have these concrete cover. For example, in footing concrete cover we have 75 millimeter, column concrete cover we takes as 25 to 50 millimeter, beam concrete covers we takes 25 to 50 millimeter, and slab concrete cover as 25 millimeter. Okay, now the next thing here is spacing. So spacing is the distance between two reinforcement bar. Here you can see the bars. We have just a main bars and distribution bars, and this is the spacing between two main bars. Okay, from here to here this is 190 millimeter, and this is an example for spacing. Now in distribution bars we have just this spacing. Okay, this is the spacing between distribution bars. Now the next thing here will be number of bars. How we can just calculate the number of bars? So the formula is span divided by spacing plus 1. So what is span? Now you can see here this is the main bar. Okay, and this is going to place in this direction, and this is called as span. Now the span is the direction in which the main bars are going to place. Now here you can see this is the span, and we'll just divide it to the spacing, that is spacing of 190 millimeter, and we'll just add 1, so it will just give us number of bars over here. Now the next thing here will be number of stirrups. How we can just calculate the number of stirrups? So the formula here is actual length of column or beams, because we use stirrups in columns and beams, divided by spacing plus 1. So here you can see this is the longitudinal section of this column, and this is the spacing between two stirrups. So how we'll just calculate actual length of the column? This is the actual length divided by spacing between two stirrups, and we'll just add 1, and it will just give us the number of stirrups over here. Now the next thing here is how we can just calculate the bend deductions. So for example, we have just bend in different kind of bars. For example, we have just a bent up bar, and we have there different kind of bends. For example, 45-degree bend, 90-degree bend, and a 135-degree bend. So in that case, how we can just calculate the bend deductions? For 45-degree we use 1D, 90-degree 2D, and 135-degree as 3D. So this is very important topic, and before moving to the next lesson, make sure that you understand it well. Hope you understand this session. We'll see you in the next.